All right, welcome to my kitchen, or welcome back to my kitchen. If you followed my lessons throughout the shutdown, and this was a familiar location, I did a lot of video shooting here. It's still pretty messy, and lots of dishes piling up. So, but we're gonna do we're gonna do a little experiment, and you're gonna need your so you need your little aluminum. I gave you an aluminum dish. I'm just going to use a Pyrex dish, but just to demonstrate it. But the little aluminum dish that you have should have some aluminum foil in your bag. You should have a baggie of really fine powder. It is the one that is not labeled. Okay, that is baking powder, otherwise known as sodium hydrogen carbonate or sodium bicarbonate. It's the powder and not the crystal, so don't use the crystals. And then you need your scale. Okay, this scale, actually your scale goes to the hundredths place. My scale does not. So I will also do this at the school so you can see how it normally would be set up in a chemistry lab, because we would normally use a Bunsen burner. We'd also use something called a crucible. Some of you may have read about the crucible, and so I will shoot that video at the school. But here, this is what I need you to do. So the baking powder, if you bake at all, and you make cookies or cakes, or if you cook waffles or pancakes or anything that typically needs something called leavening. And leavening is what makes the stuff rise. So if I don't put baking powder into cookies or cake, it's just a flat chunk of flour and eggs and sugar and stuff, and it doesn't have any, it doesn't rise at all. It's very dense, and it probably does not, I don't know how it'll taste. I don't think I've ever made anything by forgetting baking powder, but I should try it sometime to see what it's like. Anyway, so leavening, you take this, and it's a chemical reaction. So if you take baking powder, sodium hydrogen carbonate, and you heat it up to a temperature of above a couple of hundred degrees. So usually we like 350 is the oven temperature usually. It has a chemical reaction where it will break down and form carbon dioxide, so a gas, which makes the little bubbles inside your cake or your cookies to make them rise, and it forms some other stuff. And so we are going to do an experiment to see, well, can we use this thing called stoichiometry to figure out what other things are being formed from the baking powder, and looking at the possible reactions. There's a couple possible reactions I'm going to give you. Using the possible reactions and using your results, can we determine experimentally, can we determine using evidence what our actual products are going to be? So here's what you need to do. You need to take your scale. Make sure your scale is on. Make sure it's zeroed. Okay, so I'm going to zero my scale. And you're going to take your aluminum dish. Normally it's an aluminum dish. I have Pyrex dish here. You're going to put that on a scale. Doesn't matter. And you're going to write down the mass of your and just do this on regular notebook for now, because I will show you how to use the lab notebooks a little bit later. But I don't have a lab notebook with me right now, so just put this in a regular notebook. Jot down the mass of just the plain aluminum dish and write that down. Make sure you label your and if it's make sure you write down every single digit on the scale. So the mass of the plain aluminum dish. Then you're gonna take your baggie here. And you have a blue scoop. You can scoop some stuff out. I think if you dumped out everything, it should be okay. But I'm not exactly sure how much I gave people. I just scooped them a bunch of things. But you want somewhere between, I'll say between 1.5 to 2 grams. Okay, so you don't, it doesn't really matter. If you go a little over, that's fine. But you just want to scoop in. So on the thing, so I'm gonna go ahead and I'm just gonna dump some in here. You can scoop or dump it. Okay. Yeah. And obviously, you would make sure you use all the digits. So if you have the hundredths place on your scale, absolutely, you got to write down all the digits, okay? So you have your container empty, you have your container with the baking powder in it, and then what you're going to do is this. You're gonna need your oven for this. So you're gonna need to heat it up to a temperature higher than, I'll say, like 350. If you happen to have a batch of cookies that you want to throw in the oven at the same time, I think it should be okay. I don't think it's gonna ruin your results, but to be safe, I guess maybe you can do the experiment first and then do the cookies afterwards, or vice versa. So what you're going to do is you're going to make a little cover for your dish, but you don't want to totally cover it. And why is that? Well, what are we producing in this experiment? Some gas. We want to make sure the gas escapes. So we're going to take a little thin aluminum foil, and you're just going to, oh, that's not big enough. Well, you're going to loosely cover it. So loosely cover it like this. You can have some openings on it. That's fine. You want it open, but you don't want to totally seal it off. So have it loosely covered. Normally, if you use a crucible, I'll show you what you do with that. And then you're going to take your oven. So your oven would be on. I don't have my oven on right now, but turn it to, I'm going to say 350 degrees Fahrenheit. Okay, so jot down what your temperature you're going to use, and then go ahead once it reaches that temperature. I would get a cookie sheet. Get a cookie sheet and put it on your cookie sheet. Okay, and then just put it in the oven. I'm going to say for half an hour. I know that might be a little long, but we want to make sure that it is totally reacted. So I don't know. I've never done this at home. Normally we would heat this up in the crucible at temperatures of over 1,000 degrees Celsius probably, and we would just make sure that this thing is totally reacted. But you want to make sure that it is completely reacted. I'll add another note. Make sure your baking powder is not all in one giant clump. So spread it out. Make sure it's spread out. And I don't think you need to. I don't think you need to do anything to it. Just stick it in the oven, half an hour at 350. Take it out, and then you take it out. It's gonna be hot. Let it cool, but keep the cover on it. Okay. So we don't want anything to land in it. We also don't want any condensation while it's cooling. We don't want the moisture in the air to get really into it. So just keep it loosely covered. Let it cool for, maybe at least 5 minutes, so it's totally cooled. Maybe 10 minutes. And then weigh it again. Okay, don't let it sit too long. Like 10 minutes at the most. Go ahead, weigh it again, and then record the mass of, no cover. Don't forget to take the cover off, because we didn't weigh the cover. Weigh it uncovered, the dish, the now new stuff without the carbon dioxide, and then get the total mass of that. And from that, figure out, we're going to do some calculations. We're going to figure out like how much mass did we lose, how much carbon dioxide do we make, and then can we go from there to figure out what chemical equation we actually did. Okay. Okay, so these are the 3 reactions that are possible for the decomposition of baking soda. And what I want to do is kind of think and process through what we can do with our results. You have the mass of your starting material, and that is this substance here. So NaHCO3 is sodium hydrogen carbonate, and each of these 3 things here, is a possibility, okay? So you have some amount, and you weighed that, and you figure out how many grams. And then we stuck it in the oven, or we heated it in a crucible, and after that happened, we got a new mass. You should have weighed it again and get something else. And when you have that, it's one of these possible things. So this right here, or this, or this. We have NaOH, sodium hydroxide, Na2O, sodium oxide, or sodium carbonate, Na2CO3. And what we're trying to do is figure out, well, can I use stoichiometry? Can I use my knowledge of conservation of matter to determine from our data which one of these is possible? So in your calculations, in your pre-lab, what I need you to do is this, and we're going to talk about this in class, but if I have a starting amount with your starting amount for each of these 3 reactions, figure out how much of each of these solids, how much of this one would you make, how much of this one would you make, how much of this one would you make, get the grams for all these 3 things. Okay, so I want the grams for this, the grams for this, and the grams for this. When you have those calculations, so you have 3 calculations, then take your data and see how does it compare to these 3 numbers. Does it match one of them better than the other? Is it close? Is it really far off? And we're going to do something called, figure out what percent error, or how much error is there in that. And I will show you how to do percent error in class, but you're trying to figure out what's the big, the real big difference here, or is it a small difference in one of these 3 values? Okay, so good luck with that. Calculate away.